right? So what you find is you're often utilizing these languages perhaps to make piece of software or any such thing, right? Or perhaps you might have seen on certain websites that you know you click on a window or maybe and some fireworks starts or maybe some fish they start moving here and there. And these are something which are perhaps written in something called as JavaScript, and it runs natively on your computer itself. There are other languages in which there is client side and then there is server side. So maybe some program runs online on some server somewhere, and it, there is a software which is on the client side which is running. So for example, in this case, it's Zoom is running onto your client. Zoom is running over, but at the back end there are a lot of things going on, right? So even though if the internet speed is quite slow, on the server side they are tackling, or there are programs and algorithms which are tackling the issue and still providing a seamless way in which this communication can happen. But what often we find is, back in around 2000 something, there was this large gap between technology and what you will see is, since the technology was only limited to a few set of engineers, uh, artists found it often difficult to work with technologies. And in around 2000, basically, uh, John Mather, or before that, tried to advocate about this. Because John Mather was really into this computational graphics and computational art. This guy, John Mather. Uh, Two of his students, Casey Reyes and Benjamin Fry, said, okay, so if we are writing code or a set of programs to create something creative, why not create a tool which lets us be creative? And that is how in 2001 at MIT Media Labs, uh, processing was found. And it is this really nice piece of software where it enables you to actually question the status quo of all the existing softwares that you have. And you can create your own tool, your own set of softwares through processing. You can perhaps also make a business out of it. And processing is this really important piece of software. It was heavily influenced by John Mather's work, Design by Number, which again is his language. It was a very simple interface, but it really inspired processing, and there were so many other languages and environments that got inspired from it. For example, if you might have heard of Arduino, which is a microcontroller, or you might have heard of Scratch, which is again a programming language, a visual programming language for that matter. So processing is this really amazing piece of software or language, which by writing only a few lines of code, you can create this really amazing output. And it is not just a language, what you can see, but processing is basically a community of people, like-minded people who like to question the status quo, who like to break rules and create something on their own and of their own. And they often deviate from all the existing norms of how these proprietary softwares and other things are. Processing is heavily influenced by Java. It is a much simpler version of Java, and it is influenced by design by numbers. Uh, PostScript is something which is used in PDF. There are different versions also. So like processing.js is another version which is sprouting from processing. And in very recent cases, there have been certain advancements. So we also have e5.js, which is they have even simplified it even more, the processing. And it is a complete online language for creating web software or web interfaces. And this is also a really cool thing to learn. But it is based on processing. So I would want you all to uh, just follow up with me. So I want you all to go to this website and download processing. So I would have shown you exactly how to do that, but my net is really slow. Just go to processing and download processing. You will come on this page, and whichever software or OS you have, Mac or Windows. So I am using Mac, so I have downloaded processing. And when you download the folder and you unzip it, there'll be something written as processing.exe in Windows or .dmg, or maybe not DMG, it's a simple Java file. You just double click it and it will open up. So if any one of you can just text me if you have received anything in the chat. You are seeing this interface right in front of you.
So we have now opened the chat for questions.
Okay, great. Alright. So what you see in front of you is basically you might be seeing it maybe on the top left corner. This is the menu, and this part is basically your toolbar. Play is for running, and again this is the stop button, so you can stop the program. You can create different tabs, just like you have tabs in Google Chrome. Create different tabs for writing program. This part is your text editor. Whatever messages and other things you get, uh, you will find it over here. And then this is the console area, which while the program is being run, it shows what is happening. There is also this display window. When you press play, this display window opens up. So let me just give you a quick example. Right. So you might be seeing. Yeah. So this is what you might be seeing in front of you, right? And when you just press play, you have all this display window coming up and other things. Uh, Also, so I'll just quickly give you a walkthrough. You want to change certain settings, so you can perhaps just go to preferences and things. So for now, I mean, font size 12, it might be too small for you guys. And what you can see is that this is basically the messages you're getting. Like I said, compiling, it starts compiling beforehand before the program runs. So you see there is certain error which is showing it is missing a tool. So let me just first go to preferences from over there, and let me just increase the font size. So I hope you can see it big here. Fine. So we have written this thing. Size is basically to display or define the size of your display window, this window, and I can maybe just change it to anything. Right? So I have made it. The length is, you know, the width is 100 and the length is 500. Or I can simply change it to 100 by 100, which is really the default size. So this is how it happens. So let's just for now keep it 500, normal 500. And it is better that you guys also simultaneously start coding along with me, because really there is nothing to break in this thing. So you experiment a lot with this stuff, break things, make things, cut, copy, paste, mix and match, and eventually create something. So I know we have discussed that, creating a software level and so many things, but here we are starting from something, just a small window. So I really understand that this might suck initially, but uh, it will eventually get interesting. So we talked something about syntax when we were discussing initially, right? And what we mean is that suppose I have written size and I give as many number of spaces over here, right? But still I see that my program runs and I'm still getting this. There is no issue if you increase, maybe give any amount of spaces in between. It will run. It is fine with that. But if, let's say, you start changing the meaning of the program, I will just come to that. Uh, By that, I mean, let's say that you make it capital SIZE. So we see that there is an error, size does not exist, and it will simply does not run. You see this, the function size int does not exist. And that is because processing is a case sensitive language. So whether you're using capital alphabets or small alphabet, it really matters. I cannot write something like SIZE because I is something different, C is something different. And again, you see there is an error, right? So the size has to be uniform and the meaning should remain that is semantics or the syntax should be retained. Uh, Further, what you'll see is you have the set of examples right in front of you. So if you open any example, let's say, let me just let's just open this letters, right? So draw letters to the screen. This requires loading font and etc. etc. And so this program has simply printed certain letters on the screen. Or let's say, let's just look into something else. Let's say I look at colors or something or linear gradient. So simple gradients are being created through code and through these lines of code. And you will definitely start making sense of it and eventually get to do more of them. Um, there are certain demos you can find and different libraries also. And really I'm trying to see something which can actually, which is animated. So let's say this one. Left and right to change font. Right? So now by moving the mouse, this clipping is happening to this cube and other things. And really, sort of, these are just a very basic things which are possible. But at a more advanced level, there are things which are much grander than this. So, for example, let's say, let's just look into this. Right? So you can also create basic shape and other things. It's funny because I'm trying to look for all the cooler programs, but I cannot recollect it right. But these are things which are opening. And you can really have much more interesting stuff going on in these things. Um, let's say that I open this thing, you have to do this. If mouse is drag, so so I'm not sure if you can listen to what is happening. Can you guys hear if anything?
Yes, yes, yes. We are only able to hear your voice.
Achha, so you're not able to hear what is happening on the screen.
Yeah.
Let me just quickly change the setting. Sharing settings, right? So I'll just disable it for a minute and I'll quickly enable it again. I'll just enable the audio. Okay, so I hope you can hear something now. Something audible?
No, sir.
Okay, fine. So for all those students who are not able to see what is happening, so let me just turn on my camera so that it does not become awkward by that display. So what we are seeing is basically whenever we are moving the mouse, there are these different sound waves which are being created, and I can hear this sound in my earphones, which is over there, and it is all being mapped through the mouse function. And these are really some sort of small programs that you can create in processing. Yes, Abhijit, you wanted to do something. You are raising hand. I hope you guys are listening to what is happening. So anyway, fine. So now let's look at it from a programming perspective as to what is happening. Um, so getting back to presentation, right? Um, so let's say now that we want to make something, right? And let's just start with a very basic thing of creating a line. And we'll start really with suppose you were to draw something on a piece of paper, right? And what you see is basically you draw a line at certain points, which is so draw becomes your verb, or basically it is a function that has to be achieved. And these set of parameters, which are really points in on a piece of paper, and we require four of these parameters at least, that's or basically two parameters in terms of x1, y1, and your x2 and y2. These things. And what you really see is it is coming from a Cartesian coordinate, which you guys might have recently studied about or are perhaps studying about. So right, this point comes 1 comma 1, and this point comes 3 comma 3. And when we are writing, working on it, so this is how your line is being created. So in processing, uh, when we have to draw this line, we will be utilizing certain functions or a certain keywords. But before going ahead and telling you exactly what about line, let's just first discuss what exactly is happening. So you found that this is your display window, right? And in your display window, uh, like unlike your typical coordinate system where your 0 0 is the center point and the positive direction basically is on, sorry, the y is positive is over here, and for x positive is on this side, and this is negative, and this is negative again in y. Unlike this Cartesian coordinate system, which you are familiar with, uh, in processing, what happens is the coordinate system basically starts with 0 0 from this point. All right. And what it means is basically your screen is divided into these so many um, small lights, right? The small pixels, which you can say. This is just a bloated view of it. It's not an actual visualization. So you see all these things, and really, this is how the points are moving in processing, and for that matter, in your screen. So uh, this is again a positive direction in y, and this is positive direction in x-axis. And above directions are taken as negative, and this one will be negative. And you will eventually get to understand what is. So let's say that I want to draw a small line. I want to draw a line in this case, right? So there can be a very simple program line which starts from 0 0, that is from this point to 100 100. And what you really see is the size of your display window is 200 comma 200, and this point 100 100, that is x2 and y2, are located at the half point of your screen. And really you can experiment with this thing, simultaneously as we are speaking. You can also work along with me. So let's say that I simply go to the processing and I create a small line, and let's just start this line with any place. Let's say that this line starts from 20 comma 20, which really means 20 pixels along the x direction and 20 pixels along y, but this will be too small. But nonetheless, let's just small and 100 comma 100, right? it is important to close this thing. Semicolon is important after every line. So 20 pixels down and 20 pixels in the x direction over here, that is x1 and y1. And then coming to this point, that is 100 pixels from over here, origin 100, and 100 pixels from this point. So this is a very basic set of program that you have for drawing a basic line in processing. And size, again, like we were discussing, is a function, and these functions are really basic building blocks of your program. And you can provide certain arguments to them or certain parameters inside, and then they work accordingly in whichever parameters you have passed. Right? And similar for line. Line is again your inbuilt keyword, and you are utilizing these things. So a very good thing in processing is that you see the color changes, right? Similarly, there can be other shapes which can be defined. Fine. So for line, we have parameters like x1, y1, x2, y2. We can have a triangle, quadrilateral. A rectangle is something interesting, and I'll be touching upon that. You have an ellipse. You can also create an right. So let's just go back to processing and see how these things work. I hope you are able to see this screen. All right. So now what we see is we discuss something about ellipse, right? Um, and again, for ellipse, the whole thing will again start with just, so again, if this is your axis, you know, this point and this point will be x, y, and this point will be your height, and this will be the width. Right? So if you see, there is width, there is height, that is these things, and x and y coordinates which are given. So yeah, let's jump. So again, so I have given 500, 500. So let me make a circle at the center. So let's say it is 250, 250, and I want to keep the size as 100 and 100. So if the size is equal, then only we see that perfect circle will be made. There is no keyword as such circle in processing. So because if I just change to 200, you'll see this thing increases. Or maybe let's make it 500. That is just expanding all through. The width is equal to the screen size. So this is about ellipse. Let's just keep it to 100, right? Rect function is also very similar. It is for making squares and rectangles. Again, there is no thing called as squares. There is rectangle. And again, let me just make it 250, 250. That is at the center. And let's just keep it 100, 100. So you might expect this to appear maybe inside the ellipse, but no. What you see is the center is coming to this point, unlike the ellipse. So let me just, remove the line, and what I'll do is I'll simply put double slash, which means I'm commenting it out. And comments are a good way to know what you're doing in the program. I'll speak a little bit more about it in some time. Let me first just make a very basic element of design, which you all can perhaps say it is point, right? And I want this point to be at 250, 250, that is at the center of your display window. But hey, where's my point? I cannot see the point right now. Okay. So what you're seeing is, um, so let me just comment out ellipse, or let's just say that I have. deleted these two things for now. Let's just say that I have deleted these two things. Uh, Line does not exist. So point. So there is this very small dot you cannot see. So let me just make it bigger, and this brings us to properties of shape. So what I'll do is I'll use something called as stroke weight, and let me just give the weight size or thickness as 5, and what you'll see is this point over here. Now, let us draw an ellipse, right? So these were things I had cut out before. So I make an ellipse, and I now see that the outer side of ellipse is bigger, and I can also see the point, right? But let's say if I just make the ellipse come down over here, I am not able to see the point. So what it means is this program is being run in layers. So first it executes this point, second it will execute this one, third it will execute this line, fourth like this, right? So let's just keep the stroke for point itself only and not for ellipse. So ellipse will appear first, point will appear second. Now what you see is that the size of ellipse, the stroke or the outer border is not big like your point. Let's again go back to rect and let's make it 250, 50, right? And 100, 100. And what you will see is basically that your rectangle starts basically from the upper left side. So for making a rectangle, this is the center point and not this, right? So what we have to do is we have to define something called as rect, and we have to keep it at center. Okay? So now you see this rectangle has completely covered this whole ellipse. And now if I bring ellipse down, I have this very basic shape. And there are really other sort of things in the sense. So let's just first go back to. All right. So I hope you guys are understanding how you can go ahead and start creating basic shapes. Uh, then you have something called as an arc, right? And arc has again a starting point, an ending point, and certain angles with which we want to make this thing. And unlike your again traditional things what you have studied in trigonometry, that is 0 pi by 2 or 0 90 degree, things go from 0 to pi by 2 like this in a clockwise direction. Right? So I'll come to arc in a little while, but let's just first go back to processing. All right. So what we see is there are important functions like suppose I have given stroke over here, and this will really sort of change the width of my borders. What I can also do is I can use something called as smooth, and what it will do is it will make the borders much smoother. These lines are much smoother. There is also something called as no smooth, which really makes it rough. So I hope it is visible to you guys. I, but no smooth and smooth cannot be used in the same program. So it will give an error. So let's just keep it that way right now. Now let's come to arc. So what we find is for arc there has to be a starting point. Let's say that the starting point is again 250, and let's say that it goes to 300, and from 0 to pi by 2. So pi is again a system keyword which has to be in capital, see the arc starts from this point at the center, and it goes in your complete, what you can say, width and height, starting from 0 to pi by 2. And right now it is open, so I think, right, so chord, yeah. So if I make it chord, what happens is it just closes the 2 points over here. If I make it close, see this, see this thing is very slow. Okay. Anyway, um, so there are different sort of keywords which we use to define how we want to close our chords. So in this case, suppose I simply want to make the borders all throughout, right? So I use something called as pi. Okay? And if this page was opening, so anyway, yeah. So this is how pi or this thing works. And let's say if I want to make it 2 pi, right? So it is a circle, right? 0 to pi. Or let's say what happens if I make it pi by 4. Right? So I am getting a pizza slice. That is, right? And the center is starting from this point. Fine. Uh, I am going on and on about shapes. There can be really so many things you can do with this. All right. And the movement is something which you have to notice that it is always clockwise. Now, for making more complex shapes, we have something called as begin shape and end shape, and we give really vertex. And what this means is basically we are defining several points on the coordinates. And what it means is basically that if you were to draw something on your graph sheet, right? Let's if you draw anything on your graph sheet, it's distinct, right? So this point connects to this. So you have point one, point two, point three, 4, and 5, so forth, right? Which I will discuss. So let's just create any basic vertex, right, on processing and see what happens. So I simply go over here, I go with begin shape, and I have to close this. And let's say that I have to define the screen size also. Let's say the screen size is, and vertex x1, y1. So let's say x is 100 and y is 50. I'm not sure what we are going to make, but let's see. Then I give vertex. Let's say I give it to be 50, comma 240. I'm just giving any random points, and then I say end. Done. Okay, great. Since there were only 2 points given, so you have just these two as a line, right? From this. Now let's introduce third point, and maybe let's say that this point is located on 3 by, so you get something like this. You have your triangle. You can also give triangle through triangle command, but this is vertex, and let's just even give it more time. Let's just make it at 30, 120, right? And you now have a quadrilateral, and just this to be, let's just make it now. Right. So you have something over here, but you see that this point is open. So let me just comment this last one out, and let's see again. Um, you have these points, and this is not closed, right? So to close this, we simply use this as closed. And this really sort of is right now simply using keywords or commands to create very basic level shapes. So, having done that, let's just jump into a very basic activity for you guys, and I'll give you a quick, let's say, oh my, time is really about to be done. So I will not give you any more time. You can submit it later on. So draw 4 points on 4 corners of the experiment. This is an activity which you will do. Okay, now let's jump to colors. Fine. So now I want to fill colors in my, what you can say, the ellipse and other things which I have been making. Right? Size 500. Okay. So I have an ellipse, and I want to. Okay, let's just keep it 50. So I'll also come to this point. Right. So what you see is basically that 250 comma 250 is half of your width and height. And what I can also do is I can simply write width, and you see it has turned blank. And width is basically a system variable. That means it is predefined thing. So I can simply keep it width by 2, and I can keep it at height by 2. And by doing this, basically it saves me the trouble of, you know, always finding where the center is. So let's say now if I simply make it at, let's see, let's give it a very odd thing. 700 comma 200, by default this thing will be placed at the center always. Fine. Unlike, again, let's say, um, so let me just copy this thing and make one more ellipse. 50. Um, Fine. So what we see now is, so let me just reduce the size of this thing. Let's just bring it down. Okay, yeah. So right now what you see is we have these two ellipses again at the center, but I have used a system variable at this point, and let's say that if I make it 600 comma 600, the center for this thing is well defined, but for this one is not, right? Because it is still stuck with 250. So it is better if you define this, or you can utilize something called as a variable. And variable is really a place we store in the memory of the computer. So let's say that I call a variable called width is equal to width, right? And I call another variable height. Let's say this call it height. All right. So now I think we can simply replace this by w by 2 and h by 2. And let's say that again I can replace it by, let's say, w comma h, oh, sorry, w h, and you might know where this will land. This will perhaps land up at the bottom of your screen because it is 600 comma 600. Yeah, so this is coming over here and this is over here. But I can also make it at w by 2 and heading come in the center. And now, irrespective of what I keep my screen size, the center will always be the same. This is weird number. Okay, fine. Anyway, now quickly jumping to colors. So I now want to give my background some colors. So there is this command called background, And if I give 255, which means it will be white. By default, the background is gray. So you see the background has become white, but if I give it 0, the background becomes black. And why that is happening is basically because you have your colors which are going from darkest, which is the 00 value, to the white part, which is 255. And really, if you see that, um, if you just jump to this thing, and if I, instead of giving one parameter, 255, I give it, let's say, three parameters, 255, 0. So what happens is it now becomes red. So it becomes R, G, E, red, green, blue. So now, if I want to create, let's see just what happens. If I give red as 0, green as 255, and blue as 0. So you have a green screen. And if I give as 255 over here and 0, you will see a blue screen, right? Let's just create some color of pink, which basically involves more of red and little of or somewhat less of blue. So I start getting different variations in color. Okay. So this is how we go with colors. Basically, 000 being the black one, and the bigger one being 255, which is the white. And if you give three parameters, it becomes RGB. Now, again, an interesting thing. If I want to fill the color in an ellipse, I will, let's say I want to give it yellow. So let's say this is color for yellow. Okay. And I want to define the color of my second ellipse as something different. Let's say I want to keep it as green, dark green. So I get something like this. So the background is red. Okay. Now let's just shift the position of this ellipse by a certain unit, let's say 100 pixels, to, since it is a movement in x, that is the width. So what you will see is it moves a little bit over here. Let's just make it a little less. And what I'm going to demonstrate right now is another property of color. So right now, what you see, this was the origin for this green circle. We have simply used a basic arithmetic function plus operator in this case to move it to this point by 50 pixels. So from origin plus 50 by a bit. And let's say I want to change the opacity of my fills. So I can again go from 0 to 255. In this case, let's say if I give 20, what you see is a very tiny, very small amount of green. But let's just make it a little more. Let's just make it, the time is about to be over. So sorry, guys. But anyway, right? So this is what is happening now. So quickly jumping. So this is how basically a fill works. Again, there is a hexadecimal value which I'll discuss tomorrow, and these RGB values. You can really use a color selector also in processing, and which you can go from through tools and use color selector to select whichever color and simply copy this value. You can either copy this value or another value and simply maybe use it over here as like this, and you get this red fill. Okay, so now let's just jump to this part. And so this is also an assignment for you guys, an activity. You have to draw a smiley in process. Uh, let's just try to recreate the work of this famous Dutch painter, Piet Mondrian. And this is his piece, basically red, blue, and yellow composition. I think it was done in 1942. And what you see is really, if you can simply break it down into different rectangles, 1, 2, 3, 4, 5, 6, 7, right? And approaching a problem by breaking it into chunks. So what I have done is I have actually pre-baked a code from before. So let me just that. So this has been done through code. Sorry for that. Okay, but nonetheless, so I have pre-baked this code in front of me, this one. And what we do is basically we are simply creating this. This looks complicated, but actually it's just trying to figure out the simpler one, which I have the impression sketch. So this is the one. Right. So what we see over here is that I have to find a screen size, a screen weight, depending on how the background is white in this case. Translate is something which shifts the origin, and then all this program which basically converts this thing into the line. And if I remove translate, so what you see is that it goes right to this point. Okay, so at this point, I think I'll quickly take in several questions because I am way past the actual time. So I'll just open the floor for you guys to just ask me any questions. Yeah. Uh, so Faisal, are you there?
Yeah, yes, I am there. Actually, I have posted two questions which I am received from.
Yes.
Can you please repeat the name of the software?
Yeah. It is processing. Oh my god. So the whole time I have been demonstrating and you guys were not listening or working with this. Sorry.
So
Processing.
one more question is from the Anmol. Sir, can you please share me the functions used in processing?
Yes, I very much wanted to do that, but my net is okay, fine. So if you just go to references, right? So if you'll find all these things, I hope you can see my screen. So you have all these functions which are there right in front of you. So in processing, simply go to references and you have these 2D primitives and some other things. Okay, so we have discussed primitive shapes today. So that thing. I hope you got this assignment, but this is your assignment for today, where you have to replicate Pete Mondrian's New York City artwork. We have to mail the assignment. So Faisal, how will they be taking the assignment?
Actually, they have to send an assignment on the email ID that we have mentioned.
Okay,
Inquiry at the
great.
rate ups.ac.in.
Okay, great. So what I'll do is I'll send these assignments to you, the activity, and you can circulate it to the students. Is that fine?
Pardon. We just announced here the assignment and
Acha, acha.
they
Okay.
have to send. You just announce the assignment of the day. The student have to send the assignment on the email ID inquiry at the rate ups.ac.in.
Okay, great. So
That,
fine.
yeah, that we have displayed the slide.
All right, all right. I'm so sorry for that. Yes. So this is your assignment for the day. Okay. And these are different activities that you will engage in, just as getting your hands clear. But this is your assignment. You have to create Wade Mondrian's New York City 1 1942 painting on processing. I hope it is clear to everyone. Okay, any questions? All right, so I think I can wind up for today.
one is asking about the time limits. Time limits. The assignment you have to send by today itself. So kindly
Yes,
let's share the slide number 2 or second last where we are having all the information about the logging details and assignment. Second last is yes, yes. This is the slides. The all these assignments you have to sign on the email ID inquiry inquiry at the rate qqs.se.in. All assignments you have to send on this email ID and few instructions about the certifications. Student have to log in on Zoom only with the names you want on the certificates. The email ID of login should be the same at date used in the registration form. Complete attendance required for all 5 days. Submission of assignment activity on the daily basis on the below email IDs. I think
okay.
all is clear. So
Yes,
I am taking the last question from Arshdeep. Sir, can we make 3D drawing also?
yes. You can create 3D drawings in processing, but for this assignment, you only have to create this one. Okay. So remember, for this assignment, Pete Mondrian's New York City one. Just Google this thing and you'll find it. Download the image and be very careful finding where the colors are hidden and how the lines are moving. It is done in mobile also. Yes, it can be done in mobile. You can download APDE from Google Play, uh, processing for Android. But better do it on computer if it is fine with you. Otherwise, you can download APDE.
So dear students, already 7 past 4, so it's time to wind up. Thanks, Dr. Anmol, for valuable insight on these topics. Thanks, students, for attending this workshop. Learning will continue tomorrow, same time, same on various new topics. Till then, bye to a very goodbye to all of you. Stay safe. We'll meet you tomorrow at the same time for the new topics.
Thank you so much. Thank you. Thank you. Goodbye, everyone.